96% of marine life vanished. This was Earth's greatest catastrophe. A welcome to the end of the Paleozoic era, the Permian period. But this event, the Great Dying, remains Earth's most severe extinction. And the transition was swift by geological standards, spanning perhaps a million years. A Pangaea dominated the globe, creating massive continental interiors. This configuration already stressed ecosystems, setting the stage for collapse. The true trigger, however, lay deep beneath the surface. A massive flood basalt provinces began their terrifying ascent. And we now enter the Siberian Traps event, a colossal outpouring of lava. This wasn't a single volcano, but millions of square kilometers erupting. The sheer volume of ejected material dwarfs modern geological events. But the primary killer wasn't the lava, but the invisible gases released. Sulfur dioxide and carbon dioxide were injected globally, rapidly changing climate. The initial phase introduced rapid, severe global warming. The ocean temperatures soared, likely reaching lethal levels for many species. Marine ecosystems suffered immediate, widespread thermal shock and deoxygenation. On this anoxia, lack of oxygen, created vast oceanic dead zones. And even the base of the food chain, the plankton, collapsed completely. A terrestrial life faced the dual threat of heat and atmospheric poisoning. The eruptions continued for nearly a million years, periodically restarting the crisis. And the volcanic CO2 then triggered long-term climate change effects. And this atmospheric shift led to intense, sustained acid rain across Pangaea. The land vertebrates struggled to find stable refuges or adequate food sources. The ecological fabric unraveled as keystone species disappeared. And now that we understand the initial volcanic pulse, let's explore deep-sea chemistry. The volcanic warming destabilized methane hydrates trapped beneath the seafloor. But this massive methane release created a runaway greenhouse effect. The atmosphere became saturated, trapping heat far more efficiently. The resulting sustained high temperatures baked the interior of Pangaea. Many terrestrial species simply overheated beyond their biological tolerance limits. The ocean circulation slowed drastically under the thermal stress and stratification. Vast swamps and wetlands, once biodiversity hotspots, became methane factories. The oceans became acidic, dissolving the shells of surviving organisms. Survivors were often those capable of entering dormancy or surviving low oxygen. For nearly 10 million years, recovery was agonizingly slow. And now that we understand the global climatic death spiral, let's explore adaptation. But the early Triassic was an era defined by simplified ecosystems. Certain groups, like the Lystrosaurus, exploited the sudden lack of competition. The removal of competitors opened ecological niches almost overnight. Plants that could tolerate high heat and poor soils began to dominate. The recovery curve shows an initial boom, followed by long plateaus. Ocean chemistry remained volatile for millions of years, hindering full recovery. Geochemical signatures clearly record the massive carbon spike from the eruptions. While the scale was unparalleled, the mechanism, massive volcanism, is understood. The extinction resulted from positive feedback loops amplifying initial stress. The survivors paved the way for the rise of the archosaurs. Life adapted, but the world remained fundamentally changed for epochs. Studying this catastrophe teaches us about planetary resilience thresholds. The Permian serves as a stark warning regarding rapid carbon loading today. On the speed of change, not just the magnitude, dictates survival. When multiple stressors hit simultaneously, ecosystems buckle under the combined weight. The only true winners were the microscopic life forms thriving in the chaos. The physical scars of the Siberian traps remain massive geological monuments. But these sedimentary layers are the silent witnesses to planetary trauma. It took millions of years for global weather patterns to normalize fully. The survivors carried the legacy of near-total erasure into the next era. We revisit the complexity lost, a tapestry undone by planetary fury. The Permian extinction proves that geological forces hold ultimate power. Understanding the Great Dying is crucial for comprehending planetary survival limits. Life always finds a way, but the cost of near extinction is immense.